Alright, finally live. Sorry about all the delays. Yeah, this computer is not behaving. It's actually being scheduled for being completely wiped and reinstalled because it's starting to really annoy me. Alright, so yeah, I mean, long story short, like I just left for a few minutes, came back, computer decided that it was a good idea to suspend, which it's configured to never do. So effectively my session entirely crashed. It suspended. I logged back in again. Things mostly worked except for all of the Bluetooth stuff not being functional. So I had to manually fix all of that. And I still have a problem with the GPG agent not running, so I can't sign any commits, which is also a bit of an issue. So anyway, I was looking at wiping that computer basically right after the live stream. So I think it's really time for it because yeah, you can't keep having random crashes and random issues on this box. Anyway. So, IncusOS, hopefully the rest of this live stream will behave. I'm not gonna get any other weird crashes or anything. Where are we at? So quite a few things happened since last week, which is good, what we like to see. So just gonna do like another quick run through of the changes, and then look at what it looks like, which it looks quite different since we've got the text UI landed now, and then start looking at the next set of changes. So that's going to be adding a service API that can control some system services. Currently, the main two I've got in mind are both LVM and integrating OpenVswitch with Oven. So we're going to be looking at the LVM side of things and see what can be done. I expect some of the bits might take a bit longer than can fit in this live stream, but hopefully can at least go through the concepts and general structure and make some progress on that. I see that Jared is asking that when was that machine last wiped? That's like fully wiped. Well, that was right after I left Canonical. That's when I reinstalled that box from running some version of Ubuntu over to Debian 12. And that's what it's been running ever since. But I've recently completely rebuilt the install on my laptop, which is now on Debian 13, and has the like a cleaner setup around how the disk is partitioned and structured, how to do full disk encryption, and also like the general security. Like my laptop uses Secure Boot for custom key, and then TPM backed encryption for the disk, and then the ZFS pool is chained from that root disk by having kind of the key stored on the first disk. So the general idea is that the laptop can, suspend, hibernate, and everything. It can reboot. It never prompts for the encryption key unless something major happened, which so far it hasn't. None of it ever triggered that. It's got encrypted swap, encrypted everything, and it's behaving pretty well. So I want to effectively replicate that on the desktop next, which is always a bit trickier because the desktop is also running like on a Thunderbolt 3 dock, and there's a bunch of extra fun to get this one behaving. But yeah, it's pretty much due to being reinstalled. One of the main blockers was just going through all of my home directory data, figuring out like what needs to be temporarily backed up elsewhere, what do I already have in Git repos in the right locations, and what can, effectively what's the craft that can just go away so I don't need to restore everything exactly the way it is afterwards. So I think I'm basically at a stage where that machine's getting wiped because it's like it crashed. Firefox completely crashed in the middle of a video call earlier this morning, which thankfully wasn't like a live interview or anything, but I just don't trust this box. It could be a hardware issue too, like a lot of it behaves like it could be a memory issue. So part of the reinstall, I'm probably also going to run a memtest 86 overnight to just make sure there's nothing weird going on that front, and just make sure I can get something stable again. So, what happened in IncusOS over the past week? As you can see, there's a lot. So it was that, right? It was till, okay, we're getting close to the week mark at this point. I think the installation, I don't remember if the installation, the installation was merged. We tried to use it and it didn't work. That's where we were at last week. So IncusOS, the supported install logic. Then I did some cleanup following that. And so if we go to what happened since, that was still part of the install logic, specifically this time changing so that make test that I keep using doesn't use the Incus image or anything anymore. It just creates a blank disk, attaches the install media, and then installs it from scratch. So it always uses the install logic now, so that's nice. Just tweaking some of the install scripts a tiny bit, nothing too interesting to see there. And then, okay, so that's the beginning of the text UI landing. So that's a new package called internal TUI, which has all of the text UI in it. And that then runs the what you see on screen, both with prompts during installation, prompts, modal dialogues showing progress during installation, and then progress during installing the applications and applying updates. So that's landed now. Then we've got some more tweaks to the CI stuff. And okay, so that part here is me landing what was shown on stream last week. So the initial REST API handler. So that's still / and /1.0 being implemented. I didn't do anything else. I just reshuffled things a tiny bit to split it between more files and fixing the static analysis failures we're getting. So that's all nice and clean, all merged. Then more tweaks on top of the UI. And after that, we've been doing some network stuff. So and there's like a bunch more pull requests that are in progress right now related to that. But one of it was adding support for LLDP, which initially I thought we were going to need to run LLDPD, which is why it was included in the base image. But then we noticed that modern systemd networkd has both a LLDP sender implementation to broadcast the system details to a switch and a listener implementation so we can get details about the switches. So we don't need LLDPD, which is why it's been removed. We've also landed support for configuring the hostname now, which required, in the case of DHCP set hostname, required policy kit, so that got added. There was a bit of a race condition where the VM would start without network, because network would show up only a few seconds later. So currently there's a fixed delay in place. It's going to be replaced by something better in probably later today or tomorrow. The config syntax has been updated now to support LLDP directly in the config. So that effectively wraps up the state of LLDP on that front. So that's basically where we're at. There's another nice development, but I need to check if it actually completed yet. Let's see. Yes, it did. Sweet. Okay. So let me just SSH to our package publishing server and publish the latest version of the Incus stable package, because that has something interesting in it. It's going to take a couple of minutes to publish. But basically, yesterday I did a tiny bit of work in Incus itself, which has now landed and has been included in the package. We've got a random... why do we keep getting test failures on these two guys? It's kind of annoying. Actually, linstall's been failing all day long, so I don't know if something changed in linstall, because we didn't change anything on our side, but I'm just going to retry these two, just try and get in the repo clean. Anyway, what I wanted to show you is recent commits, and specifically this guy, which is support for forwarding the IncusOS APIs through Incus. So that adds a /OS endpoint to the IncusOS API, which then has a handler for it. That handler enforces that the user has the ability to reconfigure Incus itself, so can edit the server config. If the user can, then and the Unix socket for run IncusOS Unix socket exists, then we forward over to that API. So that's what's going to let us talk to those APIs routing into IncusOS without needing to run curl and that kind of stuff locally on the IncusOS instance. We can just do it through Incus itself now. I'm just waiting for the package to complete publishing, because at that point, when I rebuild a new image in a minute or so, we're gonna get that included, and that will be quite convenient for the rest of this live stream. So just keeping an eye on that to see how that's publishing. All right, so back to what we're looking at doing today. I think there's an open issue for it, which is here, the service API. All right, so there's actually a few things that we can do. Actually kind of makes me want to do more, makes me want to do NVMe first, because that one's going to be actually slightly easier than LVM, might be a better example for this. All right, so general idea here is implementing a /1.0 services endpoint. Under that endpoint, we'll have then /LVM, /NVMe, /IncusOS, /OpenVswitch. They each have their own config schema, which typically will have like a enable flag if needed. So for some services like, I think IncusOS requires a daemon, NVMe doesn't really. But yeah, if a daemon is needed, then there would be like an enable boolean to control whether the service itself is enabled. And then some configuration. So in this case, we're looking at doing NVMe, specifically NVMe discovery, which is for NVMe over TCP. And that would take a list typically of network endpoints that IncusOS needs to reach out to on startup to bring up NVMe devices that we can then use for storage. So yeah, that should be the easiest one of the bunch. And that's, it's the usual kind of design of we need a separate package to handle that. That package would potentially have sub packages, or at least different files within the package to handle the different services. And then each service will need to implement kind of the same interface for getting its config, setting its config, and then what does it want to see happen on startup. So when you do the configuration, the service would be in charge of doing its own reconfiguration. Like if it's not running, it should start running. If it's already running, it should restart. But there also needs to be a hook for when the OS actually boots up, picking up the running the needed action. So in this case, what we want is when IncusOS starts up, right after a network has been applied, it should run through the service list and bring them up, which in the case of NVMe means it's going to run the NVMe discovery command. That's going to go and pull the remote NVMe over TCP devices so that the storage is available. All right, anyway, I'm gonna show a bit of how that works in just a bit. I'm still waiting for that publication to complete, but what we actually need is Trixie, which, yes, Trixie has published, okay. And everything just completed now, all right, good. So the new stable package is available, which means we can go ahead and build ourselves a new image. Here we go. So that process still really hasn't changed. If anything, we just made it slightly lighter over the past week by removing LLDPD. I guess IncusOS, the daemon itself became a bit larger because of the text UI, but not in any way that's significant for this. And I've been doing some work in changing the spawn image script that we have in the scripts folder, which is to consume the publicly available images. I still have more changes that I actually have in my local branch here, but since GPG is not behaving, I can't actually push anything right now. So I'm going to need to sort that out afterwards. But just a small change, because on my laptop, I noticed that /temp is a tempfs, and it's not a good idea to increase a file size to 50 gigs when you're on a tempfs, because you're going to run out of space pretty quick. So I just changed it, since we're not pulling like 5-minute artifacts anymore. We're just, downloading a single file, which is just the raw image. It's just downloading it into a local file temporarily. It's injecting the seed, which is just a very minimal seed that says, please install. and then draws it to 50 gigs and boots it up. And there is a cleanup action that runs right after the system is installed, and that wipes the file because we don't need it anymore post-install. So it's not a huge deal to downloading a file and temporarily growing it to 50 gigs as a sparse file, because it's going away very shortly afterwards. All right, so that's that logic, but for now we're effectively running through a normal IncusOS test build, which again is mostly waiting for ZFS to build. That's usually what's taking most of the time at this point. That's what we're seeing here. Getting a bit of an echo here from, oops, yeah, this one there. Come on, keyboard. Okay, what's going on? Isn't my keyboard not working anymore now? No, that's fine. Okay. Just muting my headphones there. Okay, there we go. Just fixing. There we go. I'm not wearing earphones, they're just like on a desk next to me, and because OBS has them enabled as monitors, it was causing, like, I could hear myself delayed through the earphones on my desk, which was slightly annoying. So that's good now. And just waiting for the image to complete. The base image looks like it's been built. Now it's just building the extra couple images, so the Incus and debug images, which shouldn't take too long. While that's going on, I guess I can just do a bit of paperwork. So let's go on GitHub and issues. Dread says that he thinks the audio on the stream has improved. If it did, that's an accident because I didn't change anything. I mean, one thing that matters quite a bit is just how close to the mic I am. Like, it's one of those Blue Yetis, and even in whatever's the configuration I've got it running in right now, it is very directional. So if I'm not speaking directly at the mic and I'm just like speaking right next to it because I'm looking at the screen, that can be a problem. But yeah, I think it's potentially closer than it has been in some streams, which might help quite a bit with the mic volume. That's another thing where, like, I'm not gonna mess with that part of OBS right now because the machine is getting reinstalled and I'm gonna be on a newer version of OBS that probably is gonna have different knobs, so it's kind of pointless to do any extra work on that right now. Okay, so I wanted to create an issue with enable AppArmor because I just noticed it during the build and it's something we need to fix. Okay, so I need to enable extra security. Probably have it included in the base instead of in Incus. Copy /etc AppArmor, and I think it's AppArmor and AppArmor.d. I think they're two different files, aren't they? Yeah, they are. Okay. Set up a systemd temp files rule to symlink the expected /etc path to the remote. All right, I think that should do the trick for AppArmor. Basically, like, AppArmor is enabled in the kernel. We have the tools in the image. It just doesn't work because AppArmor, for some reason, still stores most of its state in /etc, even though /etc should really only be for user configurations, not for stuff that ships as part of packages. And because it's got all this stuff in /etc and we don't have /etc in this image, like the only thing that ships is /user, then AppArmor completely fails to start because it can't load any of its profiles or any of its configuration. So to fix that, we can do the same trick we've done for Etsy SSL, where during the image build, the AppArmor config folders need to be copied over to /user, so we actually have them in the image. And then on first boot, systemd temp files will create symlinks from those two paths in /Etsy over to the paths in /user, and that should fix it. So that's, I'll consider that to be a feature because it's been disabled on purpose. I'm just gonna make it that way. Okay, that way I'm gonna remember to actually do that. All right, so we should have an image now. Let's go look at that. Yeah, image got built, and let's test it. So if I do make test, that's using the new logic where it's not converting to QCAR2, it's not using an image, it's gonna literally, it's just creating a blank VM and attaching the image as a secondary disk, same way you would on an actual system, and then it boots it up. You're gonna notice that we have basically nothing on the console anymore. That's on purpose. We've turned off all kernel logging, all boot logging, all of that. Because if we don't, then it spams over this text UI and just makes things unreadable. So yeah, here you can see, I need to figure out how much I need to increase the screen size, I'm not sure. Okay, but that big. There we go. So that's the text UI that shows the install. So it's copying the different partitions over to the target. That goes reasonably quickly. And you can also see like it didn't bother to install any applications or go on the network, given that it's literally just doing the install. So it's doing bare minimum during the install, and then it just goes on. Normally what you will see is that message here that tells you to remove the install media, and then as soon as you do, the machine will reboot onto the target system. Because this is a test VM, we effectively do it automatically, where we tell IncusOS that it's fine to reboot post-install, and then as soon as we detect the reboot in Incus, we yank out the install media, and the machine boots with just its main disk. We don't want to ever boot with both install media and target disk connected to the system, because we use partition labels quite extensively, and the partition labels will be identical on the two of them, causing a lot of confusion. So we're really trying to avoid that. And in this case, we can see what happens in when we're running it in test mode. So the machine boots up, it picked up an IP address, that's good, but it couldn't install Incus itself because it doesn't have the package. So that's where test applications, I think, is the name. We should be able to use that. So that pushes Incus and the debug package into the image and then restarts the UI. So the UI will wait for the network to be functional, which should be about now. And then it goes and actually just did debug and Incus. I guess it just did Incus because we didn't put debug in the seed. Right, so now it's actually, the system is actually functional, so we can see initialization of Incus happened, and it shows us that we're running Incus with what build there. The OS build is listed at the top. We also have the time just so you can check that the system is not hung for some reason. So that's the current state of IncusOS. That's good, and now we can go play with the next piece of it. So I'm just gonna detach from that console. And let's just go inside it. So test IncusOS. All right, and what we really need is to make sure that Incus listens on the network. So that's pretty straightforward. There we go. And then we're gonna be adding a new API client for my machine. So let's just do that. Get another terminal here. Incus remote and IncusOS. Hopefully I don't have that remote already. No, good. And now I can list IncusOS, and I can list what's on it, which is nothing. That's good. But now we can play with the new feature, which is I should be able to do IncusOS, and then so you can hit the normal Incus API. That's fine. But now you should also be able to hit /OS, and we see /OS 1.0, and there we go. So that's the API that was implemented last week, and it's now being proxied through the Incus API. So that's really how we want to manage IncusOS, is doing it that way. So we don't need a separate network listener. We're just going through the Incus one. Now, the next step for this is going to be obviously adding more APIs and then eventually adding some client commands. I expect we're probably going to have something like Incus admin OS foo, and that will hit the OS API. If you're trying to do that on a system that doesn't support it, it just tells you that the system doesn't support it. That's basically all that you get. I don't know if my local system is running a build of Incus that has this bit in. I can try. No, it doesn't. I think my laptop does though, so let's try the laptop. I just need to make sure that it doesn't pretend to be IncusOS, because since I developed it on my laptop, it would. So I'm just gonna wipe that. There we go. Now if I try on my laptop /OS, no. Okay. Huh. That's not the behavior I expected, so I might have done an older build. Normally I should get a message basically saying that this is not an IncusOS system, instead of getting not found. I'm guessing I'm just not running on the right version of Incus now. But that got me intrigued, so I'm going to try and fix it. Hold on. Okay, so that's the main branch of Incus. We're up to date. Let's build it. I'm going to need a root shell on this machine. There we go. Just waiting for it to finish building. I swapped the Incus build on my machine. I just need to disconnect from the terminal here. Okay, so now my desktop is running on the newer version of Incus. What happens if I do /OS? There we go. System isn't running IncusOS. That's what I expected. So that's all good. All right, so now we have a way to hit up the IncusOS API directly. So that's going to be very convenient. We don't really need to be on that system so much anymore now. Now let's look at adding a services API. So there's going to be a few pieces involved with that. As a reminder, we've got like all of the internal packages are here, so we're going to need a new internal services package. That makes sense. We're going to do the usual boilerplate. So if we do the doc file services doc.go. Handles additional system services that require user configuration. Let's do something like that. And the package is services. All right. And on the API front, we're going to need a new handler. So currently I've got a API root file that has the two handlers from last week. We're going to need a few more, so I can probably fork that file into API services. Okay, and let's say we're going to want API services itself, and we're going to want API services NVMe. Okay. So the first one should just be a list of services effectively. So we can do, I mean, right now it's mostly static. It's fine. So we just do it. It returns services NVMe. Down the line, it's probably going to make more sense to do a loop and have like kind of plug-in infrastructure or something, so we don't need to hardcode the list. But when you only have one, why bother? So let's do that. So that's the main endpoint for /1.0 services, and then 1.0 services NVMe. This one's going to need to have kind of different logic depending on the action. So that's actually something we should do in the other endpoints too. That's not currently done. Let me just implement that real quick. So if the request, what's the name? It's probably method, I think. So if it's not a get, we should return, yeah, we need to return, but we need to do an error first. So response dot not implemented, I think. That should be supported. And we don't need to go into details about it. Simply not, that might be fine. So that's the NVMe one. Let's see, does that build? Because if it does, it would be convenient. Fine. Let's see, go enable 0. Yeah, it builds, cool. All right, so we've got those two. This part of the logic I want to actually put in the API root as well. Because right now, if we hit slash or slash 1.0 with post or delete or something, it will just succeed, which doesn't make any sense. Only get should really be supported at this point, so let's just do that. Oops, which one's complaining? 29. Oh yeah, the request we need the variable. Cool, let's push that. So same trick as I did last week for testing it. So we push into the VM and then do a bind mount trick in the VM to actually test it. Test IncusOS. So we bind mount this over the actual binary and then can restart IncusOSD. At which point we should be able to test it from here. So IncusOS /OS. Okay, so that works. Now if I send it to delete, not implemented. There we go. That's more like it. And we've got the 1.0. Okay, so that's good. Next, let's actually wire in the 2 new endpoints because I didn't do that yet. So if we go in the server, we've got the handlers here. So we just need to add, this is 1.0 services, 1.0 services NVMe. And this is API services NVMe as the endpoint. And this is API services. Build that. Binary, I won't be able to push it because it's in use. So I need to stop IncusOSD and you mount its binary. Okay, push that. And then we can do the reverse where we bind mount this thing. Oops. Code bin IncusOSD and start it. All right. So now if I do services, bad gateway. Oh, I guess we need to wait the network initialization delay, maybe. So what's going on? There we go. Yeah. Okay. 1.0 services is functional, and NVMe gives us not the right kind of data at all, but you know, it's there. Okay. So now we're gonna need to figure out the structure for our services, because what should actually happen is that API endpoint should be effectively pulling the, I think it should be more flexible effectively. We should be able to just list the optional services and kind of build up the API from that. And have a function for like get me the config that you want to fill. We return that, and then the user can push it back with put. Let's see if we can do some amount of that. Maybe just before that, let's actually show how the NVMe stuff is supposed to work, if I can make it work. Oh well, first problem, we don't have the NVMe tools installed. Okay, well. Sorry, that's going to be a side problem. So I think it's NVMe CLI. Yeah, NVMe CLI. Okay, I'm just gonna go and add that then. And we'll do an image build while this old stuff, while working on the API. So if I go back in IncusOS, let's do, where is that? Make OSI images base, conf.d, there's like a base package stuff somewhere. Core package is 03, okay. All right, so in here, we're gonna need NVMe CLI. Okay, and let's build a new image. Can actually show how the update works at that point. That should work fine. So we should be able to do a test update and have the OS kind of update onto that image. Anyway, maybe I can show the NVMe stuff just on my desktop instead, maybe. I don't remember if I've got it configured. I definitely have the NVMe tool at least. So there's a discovery.conf thing here. So that's kind of what we need to populate based on the data that gets provided. In this case, I'm providing 3 servers on default port over TCP. So we'd want effectively that data to be provided by the user. And then we don't need that header thing, that can go away. And then once that's there, if you do NVMe list, there's just my local SSD, but if you do connect all, then it would go over the network and attach the rest. Now it's saying connection refused, which is slightly puzzling. I don't remember there being firewalling on the way there. There might be. Let me check. So this is those are my 3 servers at home, so that's kind of expected. And then, yeah, they don't respond. Again, probably more debugging than you probably want, but let's go look at one of the servers and see what's going on. Because we use those NVMe targets basically every day for complex cluster testing that's running on our Jenkins. So I know the function. Okay, apparently I don't know how to type my password today. Come on. All right. I think it's done through the script here, NVMe TCP. Yeah, there we go. Okay, this is the port. I'm just checking if there's like any kind of restriction as to who can connect to that, but I'm not seeing anything. It's bound to be 100. Okay. Let me actually go check in our CI repo. Because in there should be cluster test. There we go. Templates and hosts YAML, maybe? Is that where the NVMe stuff is defined? Remote NVMe. Okay, it just shows NVMe target 1, 2, 3. Okay, and so that's an incus deploy config. So I'm just gonna go check how it's handled. Files for NVMe discovery. Okay, we don't pass the port, so maybe just a port issue somehow. Let's try that. So if I remove NVMe, if I go in here and I remove that. Oh, that's better. Yeah, there we go. This time it's here. The connection refuse on the others is not necessarily a problem. Technically, you only need one of the 3 to function, or one of the whatever number of controllers that you have to function. And then it can learn the topology from the rest normally. So the NVMe command, let's see, there's a show topology command that I want. Yeah, here we go. So currently it's got 2 of 3 paths running. So the paths on 102 is not functional. I don't know why. So yeah, it's behaving as if one of the 3 servers is not currently providing functional connectivity. That could be an actual problem with the setup on the server, to be fair. So I'm gonna go and check that one, because that's the server that's failing is Denmark, which I know got rebooted earlier today. So there's a decent chance that something wrong happened on the NVMe front on restart, and it's just not running. Also, that password is gonna be the death of me, but come on. All right. NVMe TCP. So we're just rerunning the initialization script because that will just bring it back up. Yeah, it looks like it was not initialized for some reason. Okay. Now let's try again the connect all. Yeah, no error this time, so that's good. The error came from that third server, and now we've got 3 paths. There we go. That's what we like to see with NVMe over TCP. I mean, obviously, normally you're running that against like physical storage arrays, you're not running that with random servers. But that's still working fine, and we'll be able to test that from the IncusOS VM. Do you really want to use that block device? Probably not. Like, performance is not gonna be fun since IncusOS is running in a VM on my desktop over Wi-Fi. Would not recommend. Like, normally that's really meant for other servers to access it. Like, those machines are on like dual 25 gig network. That's more what is meant to be used. But anyway, for testing, it would work just fine. Okay. The other question I actually had was whether we need the config file at all, because we can see it's just like a bunch of arguments. So we might be able to just run that directly. It's in the discovery.conf file, so I don't know if it needs to be the discovery command in there. Yeah, so there's a discover, and the discover command. Well, I mean, I just discovered what's in the config file in it. So if I do connect, what does connect take? Connect device, sure. Can I just provide that? It wants NQN or it wants N. Okay, so I think yeah, it's kind of like a 2-stage process where like discover can tell you what's on it, and then connect does the rest. All right. So I guess the passing, like generating the config file and running the commands is gonna be easier. If it was literally runs those 3 lines equals 3 commands, that would make that would be quite easy, and we'll just do that instead. But in this case, it looks like generating the discovery file first and then running connect all is probably the way to go. So I'm gonna be doing that. Let's see, where was I? This one? Yeah. So we do have our new image. We can actually go look at what that looks like in the console, I guess. Let's close this one to test IncusOS, and then yeah, there we go. The UI just redrew, and we can do make test update. Oops, no typo. Yeah, so it's pushing the update, and it's gonna restart the UI. Eventually, we're gonna have an API for that, so we don't need to actually restart the UI to have it notice new files on disk. But anyways, it's doing the same waiting for the network trick, which is gonna be quite a bit faster very soon as we merge more changes. There we go. Downloading Incus update version 18.13 for today. Cool. And system restarting. On restart, it should just update the applications as well, because the new versions were pushed. And then we should be back on the version that has the NVMe commands that we can play with. Okay. Applying Incus, applying debug, we are good. No, again, debug is ignored because the seeds didn't ask for it to be installed. So, all right. So if we go in there, we'll need to still do the bind mount. Oops. Need to just stop IncusOSD. Okay, and do the bind mount. There we go. And just restart it. And we should have the NVMe command. We do. And let's see if we can make the NVMe stuff work by hand. Don't need that UI anymore, so I can disconnect that. Resetting the shell to have it work properly. And the discovery config, it looks like this. We don't have a text editor, obviously, in the image, so need to just do it the old-fashioned way. Which is gonna fail, I think, because the NVMe folder most likely does not exist. Let's see, NVMe, here we go. And we can just append the other two lines. Okay, NVMe connect all. Failure scan topology, no such file directory. Okay, it seems to need more. Oh yeah, we need the host ID and host NQN. Yeah, that makes sense. How do we generate those? I think there's a command to generate that. Let's see, it's probably post-inst maybe of the NVMe stuff. That would make some amount of sense. UUID gen for host ID, NVMe gen host NQN for the NQN. Okay, so let's do that. No idea if we got UUID gen installed in IncusOS, but if we don't, that's not a problem. We can just change the UUID from Go anyways. Okay, we do. All right, so now with these two done, so host NQN, that looks like this, and host ID looks like that. If we go and connect, nope, still unhappy. What else does it need? Now it's kind of annoying because we don't have debug. If we had a debug package, that would be a whole lot easier because we could actually run strace. So let's make a debug package. We need to do something along the lines of version 2, applications, and then we want Incus as an application, and we want debug as an application. That looks good. Applications.yaml, cf. We're editing directly the seed partition, part label, seed, and pushing that in. There we go. Then we need to reset the state a bit. There we go. If I do the console again and now I restart IncusOS, it should pick up that it needs to install both of them now, and it's gonna install the, well, gonna reapply Incus and install the debug package in theory. Nope, that failed. Okay, what did I mess up? Like it briefly logged an error. I would like to have seen that error. There we go. Marshal cannot unmarshal. Oh, right. Okay, my syntax is actually wrong. This is supposed to be name debug, name Incus. There we go. So let's do the double, wipe any state we have, restart IncusOS. And let's see what it picks up this time. There we go. All right, we've got debug now. So since we've got debug, we've got strace. Since we've got strace, it's gonna make it a lot easier to see why NVMe doesn't like me. Let's go. What's missing? User run NVMe, sysclass NVMe. Okay, why don't we have sysclass NVMe? That one's kind of puzzling. Because that I would have expected to have. Okay. Mode probe NVMe? Really? It doesn't do that automatically from the command? That's kind of odd. I mean, if that's the only issue, I'll take it, but I'm kind of surprised. Okay. It's complaining about other stuff. Failed to open the NVMe fabrics. Okay. Now, do I have more stuff loaded on my machine? Okay, apparently NVMe Fabrics and NVMe TCP. Fine. So let's. It looks like it really doesn't auto-load anything useful, so you're gonna need to load everything for it. Oh yeah, there we go. Okay. So that's fine. And we can see now we've got access to that block device, 536 gigs, mapped over NVMe over TCP, supposedly across 3 paths. Let's just see that that's the case. Yep, all good. And we could, initialize Incus on that now. All right, so we've learned a few things, which we need to write down before we forget. So services, I'm gonna create a new file called service nvme.go. And in here, we're gonna write everything that we need to do. So modprobe NVMe, modprobe NVMe fabrics, modprobe NVMe TCP. Then there were the IDs. So there's a UUID gen and where was that? Here, yeah, UUID gen for the host ID. That's fine. And the NQN. Okay. Yeah, that's fine. And then we can just return those IDs as part of the struct that we show the user. So that's okay. And then obviously NVMe connect all, and that should do everything we need. All right. So there's going to be a few things we want to. So that's in the package services. There's a few actions we want on those services. One of them is gonna get me the service, and one of them is put to then update the service. I don't know that it necessarily makes sense to have like a full tree of options and stuff below the service. I think it makes more sense to effectively have the service struct have some fields that are updatable, as in its config. It's a config map with key value, and the rest is kind of just its state, and we've got everything on the same endpoint, because I don't currently see the need for like much depth here. So basically for this particular service, I'm not even sure I would want to name that yet, but anyway, and just quit an API NVMe or something along those lines. I would want that's like effectively a state, and within the state we'd have an actual status string, like running or whatever, to just kind of give you an idea of the current of the service status. Then we've got the host ID, host NQN. So those would be exposed to the user that way. That's not configurable. It's just what the system has effectively. And then there's something that's more of the configuration aspect of it, which then there's a Boolean for whether the service is enabled, and then we'll be looking at like a list of targets effectively. Which then is a list of if we can do that inline. I don't think we can. It's like a list of NVMe targets effectively, and then an NVMe list of NVMe target, like that, and then each target would have protocol, address. There was slightly more to that. I don't know if we want to expose all the fields. That doesn't really make a ton of sense. There's kind of too much right now. So yeah, transport is effectively the protocol. So that's, I guess it's, yeah, the protocol is always NVMe, so it's correct to call that transport. So the transport address. I've not really seen that that it makes that much sense to. I haven't seen the keyring and that kind of stuff used all that much yet. That will probably get added, but I don't think we need to overdo it with the authentication and encryption, all that kind of stuff right now. I definitely expect that TLS will show up soon enough, because that's good practice, especially in environments where NVMe or TCP is not on a dedicated network. So transport address, port, and there's the port, yeah, for TCP transport, yeah, sure, but yeah, transport service ID, well, that's, yeah, just call it port and put that as an integer. So that's kind of the base structure I would want. If port is 0, we just use the default, that's fine. So it would just effectively be transport TCP IP address, and then we're good. So at the API level, yeah, we'd have the state, that's kind of the consistent, the current state of what's running. We could show, in theory, more details on the targets and stuff as well. It depends how much of that mix is really needed. But like we could effectively have a version of the show topology that shows the all of the detected, connected, how many links do you have, all that kind of stuff. I don't think it's needed initially. Initially, you really just need, is this thing on, host ID, host NQN. Even then, I mean, the status, I think, is not really a thing in the case of NVMe or TCP. There's no daemon running, so I don't think we need that. It's, yeah, closer to this, just config that's user editable, and then the state that is really the runtime state. All right, so that's the rough structure for what I would want as far as the API there. So that could be the main NVMe struct. As far as what's user visible, I need to put all of the right tags on there now. So host NQN. And I realize we've not really done too much in the way of fleshing out the actual API for this stuff, but hopefully we can just put something together very quickly, just gonna show the structure, and then I'll clean up the rest afterwards. I don't want this live stream to last forever either. Okay. Okay, so that's the rough structure for this struct. Oh, I forgot to give a name to this guy here. Okay, and then same thing here. Okay, so that's a good first start. Let's see what I broke. Services of NVMe 910. Oh yeah, I forgot to struct. There we go. All right. Just see how mad coding CI is at me right now. Oh, yeah, it's got some good points. All right, let's go and clean that up, at least for the API root. So instead of doing that, we should do http.method get. Was there any other one in the file? Yeah. That makes sense. All right. So it should be happy with that. NVMe, NVMe targets are unused. Yeah, I mean, technically those two, I'm trying to think if they need to be exported or not. I mean, they're gonna show up in the API and they might need to be exported eventually because of that. It's like, we don't currently have an API package with publicly available structs yet. Once we do, those will need to move in there. For now, I don't know they need to be exported. We don't actually need them anywhere else yet. So they can probably stay where they are. Okay, then we've got all of the alignment things, which, yeah, that's easy enough to fix. Okay, is that all of those? I missed something in the alignments. Nested struct, no nested structs are allowed. Why? This seems like a very arbitrary restriction that I don't think makes sense, so we're gonna just remove that one. I'm not usually the biggest fan of nested structs, but for this kind of stuff, they actually make sense, I think. What? What's complaining about return here? It actually makes sense to have it here. Return, oh, no blank line before. Okay, yeah, sure, that I'm fine with. But it was saying that the return was not needed, which it definitely is. Nested struct, API root has some issue with the returns too. Yeah, makes sense. So this guy here and this guy here. Okay, cool. Let's do that. All right, now we just have the nested struct thing, which, okay, it's a revive test. Let's see the config for calling CI lint on revive. So it's actually this guy. Yeah, and then we want, and obviously you might remember we're effectively running with all of them enabled. Which is why it's complaining about some of that kind of stuff. Okay, so we can do name and then disable true should do it. Okay, so we just need to turn off nested structs in dot. Okay, where's the down config file? Here. Revive, yeah, sure. I already have a few rules are disabled, so I'm just gonna need to add more and more. Nested structs. Are they sorted? Can I look like they are? Oh, it's actually at the right spot. Okay, fine. Run. Should just complain about the last two, which would make sense. That one we keep having as an error, which is kind of puzzling, because it says is unused for linter revive, but then eventually on a retry it will complain, because if we remove, like if we actually remove it, I'm pretty sure we're gonna get an error. Yeah, unexported return from revive. So the no lint revive is perfectly correct, but the no lint thing is just wrong. So it's really weird. Can we use no lint as a... Okay, that works. That's a bit of a hack, but need to disable the no lint linter on the no lint warnings. I don't know, it's just weird. Cool. All right, so that's that stuff kind of cleaned up. Let me just check. I think there are a few things that can actually be committed as they are. So one of them is base include NVMe. So this one can go now. Then IncusDTUI fix racing calling CI lint. So that should fix that particular issue. Then IncusOS OSD calling CI lint allow nested structs, so that one, and then IncusOS rest only allow get, because we had a few of those. Yep. Nope. Okay. So that clears that stuff up. I saw that I did some typos in my commit messages, specifically this one. So just need to go reword it a bit. Incus OSD, there we go. And then we've got the services API, which is what I was looking at. So in services, we again just have the service NVMe. What can we do to make that kind of work? Because yeah, that stuff is effectively, those are effectively API structs. So that would be like a service NVMe struct, service NVMe target struct. Effectively, that's what they should be named in an API package. So something like that. NVMe target represents a single NVMe target, and then service NVMe represents the state and configuration of the NVMe service. Right, so those are effectively API structs. They're probably not gonna stick around there long. They're gonna have to move elsewhere. Then we can have the actual service, which would be NVMe struct. And then on there, we would have so get would give us effectively a pointer to a service NVMe. So that gives us the service state, config and state effectively in one shot, as well as an error. So something like that. And then func NVMe update. This would take in like effectively a service NVMe struct too, but would only apply the config part of it. The rest would be ignored, but we can do that. So the request would be also a service NVMe, and you return an error. So currently we could just do like, as a test, we can do a blank struct, so service NVMe, and then we return. Actually, I can just do the pointer from the start, then we return that. And then update, we can return areas new, not implemented, something along those lines. Okay. And like normally as part of an update is when we would effectively internally call like stop or start, which we don't really have, but we need to implement those functions as well. So stop, this would take a context, which we may or may not use, but that should have a context. It returns an error, and this does nothing for now. And then start, same thing. Right. And that's where we will be able to, so update will take care of the config. So update will be in charge of making sure we have a host ID and NQN and the discovery config is all in place. start, stop effectively just end up running the connect all, disconnect all. And that's basically it. So long as the service is actually configured, like is enabled in some way. So I think that kind of gets us back to, yeah, we do need we've got the enabled config here. So we're gonna need to get that, which should be fine. I think we're gonna have, we need to have a pointer to the state struct, effectively to that struct internally. So that's what we can do here. And then maybe just do a function currently for new NVMe. Let's just ignore, let's just have it return some blank data for now. So new NVMe would return a pointer to an NVMe struct, and an error. Here we go. So that gets us a new NVMe struct. And we'll also immediately put a new NVMe state in there, which is service NVMe, something like that. In this, we actually need to add that struct member. So state is of type service NVMe. Okay. And we just return that back to the user, at which point they can call those functions on it. And what we'll do here is then if, so I need to actually have access to that struct. This one is n, there we go. All right, so if n.state.config.enable, so if it's, well, actually if it's not enabled, we just return immediately, it's fine. Same thing for stop. We can take that shortcut. And then if not, subprocess run command context, which uses the context. And we'll do the, like in this case, it's gonna run the NVMe disconnect all command. Like that. And in the case of start, it needs to do a few more things. So, so it needs to load the modules. And the modules were NVMe, NVMe fabrics, NVMe TCP. So we put those modules. We're just gonna do subprocess run command ctx and mod probe and the module name. So we're gonna load the module that way. Oh, I've got someone here. I'm so sorry. I'm gonna be right back. Sorry about that. Delivery driver just showed up. So, all right. So in the start case, we've got the right modules mostly loaded. Just need to handle with handle the error here. Okay. Then once we've got all of the drivers, all of the modules loaded, we can actually run the main command here, which is the connect all. Okay, so I think that covers most of the logic. So I'm missing, yeah, so these two are missing. That should go into probably need to update, really. Could go into start. It wouldn't be the end of the world for it to go into start either. If the files are missing, to just do that. Yeah, guess so. All right, let's go and do it in start. Start, okay. Okay, so if we're missing that stuff, then we're gonna go and generate them. So, and usually we're using some utils for that, for like path exists. Are we already using that in here somewhere? We don't, okay. I think we can do it with simple start. Am I doing OS start elsewhere? Yeah, in partition, okay. Is that what we're using it for? Yeah, just checking the error on an OS start. So that's exactly what I want to do here. That's fine. Stick that code over. All right, so and the first thing is we need to actually create the etc NVMe directory. Yeah, OS. Okay, so just creating the folder if missing. Then let's do the, what is it, host in QN or something? Yeah, host in QN. So that one we need to run a command to generate. So if that doesn't exist, so if it fails for something other than not exist, then we just return the error. Actually, we should do it more like this way. That makes more sense. Okay, so if it doesn't, if it's not the expected error, we'll do that. Otherwise, we generate the file. Okay. In which case, actually needs to create the thing. So that becomes f is os create of etc NVMe host in QN. If that fails, then we want to return, obviously. Otherwise, we defer closing of it. And then we actually run subprocess run command split. Of which I never remember the actual syntax. So let me find out. Run command split. What does that do? Yeah. Context, environment, don't care. File inherits, don't care. I thought it was this one, but it's not. Okay. Let me find the other commands. It's not split that we want. It's with FDEs, that's that one. Okay, run command with FDEs. Let's try that again. Context, stud in, and there we go. So that's what we want. Stud in, no. Stud out, yes. So stud out is F. And then the command, so it's NVMe. And was it gen NQN, I think? So that should then fill in the file with what we want. No, gen-host in QN. Okay. So let's do that. Here we go. So that generates at the NVMe hosting QN. That's fine. And then let's change the comments a bit. Okay, and then we need to do the same thing with this guy here. Host underscore ID, I think. No, host ID in one word. Okay, sure. Host ID. If it's missing, then so that seems fine. NVMe hosting. Yeah, that should be okay. There we go. And for this one, it's a bit easier because we can just do OS write file directly off at C NVMe host ID. And then I think it takes the permission usually, so it's fine, 644. And then the content, which is, I don't remember if it takes a string or byte, but let's assume bytes. Actually, I think the UID generator will give us what we want to. Do we already have one loaded? Not directly. Okay. Let me figure out the UID syntax again because I never remember it. It's UID new string. There we go. So use that. Okay, and the error handling here. All right, let's see how wrong that code is. Like I'm missing all the imports, that's for sure. So context of process, it's complaining here, fine. Error line 61, it's not defined yet. Sure, let's do that. Which means this one is probably not defined. No, the next one will be, okay. 68, same problem, right? Okay, so it really wants OS to be loaded, context to be loaded, and we want the process which is in Incus, so it's here. Okay, make the wants a mode. This one wants this to be service NVMe target, which then requires all that stuff to be realigned. Okay. Oh, forgot to give this one a name. Okay. Too many return values, 55. Why? What am I doing here? Oh, okay. Yeah, run command context actually, it's true, gives us slightly more, so we need to do it that way. 66, same thing. Okay, cannot use CTX. Yeah, that's a run command context we want on this one. There we go. 73, make the permissions 0700. Like, we might have some sensitive files in there. I actually did something more permissive earlier. I might just, let's just tighten things because that's not gonna, was gonna be running stuff as root, so there's no reason to be too nice about permissions. We can be pretty tight. Okay. That's the one you were mentioning, John. Okay, and then it wants to, it's complaining about write file. Does that not take permissions? I thought it did. Or maybe it wants them as a last argument. Yeah, okay. That's exactly what it wants. Okay. All right, run command with FDs. Apparently I mistyped that somehow. Oh yeah, FDs, the D is not capitalized for some reason. Sure. Okay, this guy also needs to be like that. Already have an error defined, so. Okay, and just UUID, which we usually get the Google one, I think. This guy, yeah. So that should build now. Not quite, because it does want a list of bytes. Does new? No, that's still not the right type. Okay, fine. Is there like a bytes? That'd be cool. No, there isn't. All right, old-fashioned way it is. Let's do that. Yay! So that builds. Now let's see how mad I made running CI by doing all of that. Less mad than I expected, honestly. So just gonna clean things up a bit. I actually don't like that syntax at all. I'm gonna go do my usual syntax then. If I could have made it on 2 lines like that, I would have been happy with it, but I don't like the line break in this scenario, so I'm gonna just do this instead. Okay, that's mad about something else, 116. Right. Okay. Need a comment. Yeah, I know that. Needs a comment. I know that. Needs a comment. I know that. Parameter rec is not used. Yeah, and currently this function is not doing anything. So fair enough. What else? Comment. Oh yeah, errors and capitalization. My default is always wrong. And then alignment in the tags here. Yep. All right. So Jared wanted to take a closer look at those, see if I typoed anything. Config, targets, config. Oh well, that's obviously wrong. That's supposed to say enabled. Okay, host increment, host ID, host ID, so that's fine. State is good. Port, address, transport. Yeah, that looks fine. And it's just complaining about comments, so that's fine. That's what we like to see. These two have correct comments. This one still needs one. And this one's probably gonna go away. I don't really see a need for that particular function. We're probably gonna have a more generic service loader for all the services. Okay. Get returns the current service state. Updates the service configuration. Those are pretty generic because we're gonna have the same ones on all of the services. On the interface ones, actually, the final interface. Stops the service. I mean, they're kind of pointless comments, really. But the comments within the function are a lot more useful than those on the function. Okay, is that all of them? Yes. Yay. Okay, so that's the new package mostly in place for that then. Next, we can just try to make this one just a bit of boilerplate to make it actually get the details and just play with it before wrapping up this stream that's been going on for a bit too long at this point. All right. So we're just gonna do an services.new NVMe. If we get an error, we're just gonna straight up return, and that's it. Otherwise, we're returning as the state here, and actually, an error can also happen in that state, so we need to do n.get, and here, let's see, does that build? Service is not defined. Yeah, that's fine. Let's fix that. Cool, that built. So let's just go and push that. All right, let's go in the IncusOS first. Yeah, we need the umount, so stop plus umount, push, and then find and stop the service, and from down there should be able to do query on IncusOS slash OS slash 1.0. Oops, there. So that works. And then if we do services, that works. NVMe. Yay! So, I mean, it's completely pointless because there's no config, there's nothing useful, and update is not implemented, but we can actually get the status. So we see the targets as being just now. That's not ideal. I would rather it be empty, honestly. So we could probably tweak that a tiny bit. We open not this one, I want the other one. There. Okay, so I'm gonna do it in get for now, but it's a bad place to do it. But short of having anything better right now, we'll do it in here. So if state dot state is a pretty bad name actually, but because we've got state.state, that's what's just bothering me right now. But okay, so if config that targets is null, I wonder, can we just make it an empty list and make that look slightly better? I never remember how the conversion over to JSON really works. It might still give us the exact same output. I'm kind of intrigued, so let's see. Stop, push, start. Let's give it a few seconds and see what that looks like. Like, technically this is not, yeah, not really something that should be, well, yeah, enabled is false, so that's why we have no host ID, host NQN, so it's fine for those to report as empty until it's enabled. Yeah, that looks better. Okay, we'll do that. Now we can just, for testing purposes, in the REST API, currently start can be run multiple times, so we can just do that and see if that fixes everything else. If we do the start and we completely ignore its return value, it's fine. I mean, it would be nice to know if it failed actually, but yeah. Let's do it. So we won't know what the error is, but we'll know that there was an error if there's one. Start wants a context, right? Context to do. Never imported context in here apparently. Okay. All right. And restart this thing again. So this time it's gonna call start, which should populate things at least. So in theory, I'm gonna have to actually go and wipe this stuff clean, actually wipe etc NVMe completely. NVMe disconnect all. Okay, and let's unload the volumes, the modules for good measure. So TCP, fabrics, NVMe. Okay. So now we're on a clean system. Well, kind of, that's still core. Now we're on a clean system effectively. There's no more etc NVMe or anything. And in theory, querying the service should do all of that for us now. Or not. Okay, but it should also have returned an error in that case, so what's going on? Yeah, it's as if it didn't do anything. I built this thing, yeah? Yeah. Let me check. What did I mess up? Did I not save this file? Is that what's going on? Because we called start. If we get an error, we'd return immediately, so we wouldn't have gotten the details. No, it was built. I transferred it, I did the mount dance, I did all of that stuff, so it should have worked. Let me just take a quick look at the service NVMe. This one. So the start command, what does it do? Oh, right, okay. I know what's going on. We're hitting this guy immediately. So that makes sense. The config says it's not enabled, so and we can go and tweak that a bit in the other one actually. So second file. All right, so we get it, and then let's do end. Oh, I can't access. Never mind. I can't access end.state from there, so that makes sense. Where's start? Okay, so I'm just gonna, for now in new NVMe, I'm just gonna go ahead and lie a bit, and config enable is gonna be true. There. Let's do that. I saw a mention of core in the chat. Was there a typo with NVMe in the list of modules? Not in this one down. Yeah, I mean, NVMe core was unloaded, but it's a dependency, so I don't think we need to load it directly. Okay, so let's just do query about gateway. Okay, is that just because the API is not up yet? Is that what's going on? Oh, right, yeah, I stopped it and then started back. That's why. Let's do that. Now I'm actually wondering if I remember to build and push the code. So I guess we'll see. Come on. There we go. NVMe. Oh yeah, it's good. NVMe true. Host ID and stuff is still empty because there's nothing that fills it in. That's fine. NVMe, we've got a host ID, host and QN. Oops, host ID is missing a line break. Host and QN is fine. Okay, where's host ID? There. Just needs to append this stuff with a there. So that will give us that should give us a line break. What did I mess up now? Append. Oops. Yeah. Okay. So this is the first one, and this is the second argument. Type byte. Yeah. Okay. There we go. So that should fix it. So that fixed the line break. The permission was not good on the other one, on this guy here. Oh, not, where is it? This guy here. So we're missing a f.chmod 00600. So let's do that. Just adding things up. It really doesn't make doesn't really matter too much because the folder itself is 700, so that's fine. Now, if I wipe this clean and we look at NVMe again, so NVMe, TCP, fabrics, core, and core. I think there's some mention of the underscore versus dash thing. It doesn't matter for kernel modules. You can use either way. So I use dashes. It's one less key press. So that's just that in place. I stopped it. I didn't start it back. So let's start it back. And then just wait for the API to come back. And this time we hit /NVMe. It should regenerate everything again. Okay, hit /NVMe, and we've got, yep, the two files. This time the ID has a line break, host NQN has a line break, we're good. And then I can try to manually write the discovery bits just to make sure that the config is otherwise functional. So right now I've got nothing, and if I connect all, I've got my thing showing up, and topology shows the correct topology. All right, I think I'm gonna leave it at that. There's some more cleanup around like getting an interface, changing kind of the way we load services and all that kind of stuff. And obviously implementing the update config, so it's actually possible to do a put on that endpoint with a list of targets, have that generate the discovery.conf so that those manual steps are not needed. But yeah, that's quite a bit of progress, and hopefully it kind of shows you how that stuff will work for services. As with everything else, once the first one is in place and works properly, the kind of rinse repeat for the others will be reasonably easy. Like IncusOS is mostly the same story as NVMe, a bit more manual, but mostly the same story. Doing LVM is going to be a bit different because it's different files and more daemons and services and stuff, but it's still mostly kind of the same user interaction. And same thing for OpenVswitch. And there's also mention of like, it's good to see all the progress. And yeah, and I mostly work on it kind of on and off during the week and otherwise doing this live stream. But we've got Matthias who's working on it basically full time, adding some of the other bits. So that's how we saw the network config arrive, the install logic arrive. Now the text UI is coming in, and we've got a bunch more issues and kind of pull requests and stuff being worked on right now. One actually changed during this live stream, apparently, around storing the network config in the state instead of just in the seed, because once it's applied to the system, it should be stored in the state. Once we've got that one done, then we're able to unblock some more of those issues. So if you look, once we've got the where's the state? Network seed data needs to be copied into state. So that's being worked on right now. Once that's done, it will allow the next one, which is support for fetching and updating the network config through the API. So that will be pretty good. Hostname domain config, that's mostly done. We're just waiting for a rebase and a small tweak to that, but there's a pull request open for that one. There are a couple of small tweaks to the UI. Currently, one thing that's not working is if we go on the text console, so if we do console test IncusOS, it redraws after every 5 or 10 seconds. So just wait, there we go. We've got the UI here. But if you look at the VGA console instead, the VGA console has absolutely nothing on screen. That's because the logic we're using can currently only render on one device, and it currently only renders on dev console. We need to actually have it render on TTY 1 through 7 at the same time. So there's an issue that's gonna solve that. A bit of rework on how we handle the internal state struct across packages to make it better for the UI. Apply network config. I mentioned I currently have like a hard-coded 5 seconds thing to wait for network to function, which would instead use network CTL, network header status. So there's also some work happening on that. You can see there's a pull request tied to it. AppArmor will come in. We've got an internal deployment of Operation Center that we're going to be able to test IncusOS against. So there's going to be support for Operation Center landing pretty soon, even if Operation Center itself is, the repo is not public yet. It should be in the next 2 weeks to a month at this point. And yeah, more services to be added, AppHammer to become enabled, some security stuff we are also working on for like setting the TPM recovery key. So if something breaks and you need to decrypt the disk, you'll have a key that works for that. We've got some work, a whole bunch of work actually happening on the Incus side by University of Texas students, including what's needed to do provisioning of client certificates directly into Incus during the pre-seed stage, which is going to then make it possible to inject TLS keys directly into IncusOS, so that if you're running it at home, you can actually have a key that's trusted right from the start. We also have planned work around an update API, so it's actually possible to look at updates and apply them through the IncusOS API, so you don't need to restart the daemon like I keep doing. We'll probably have like also some extra APIs for like system endpoints and stuff, so you can do system shutdown, system reboot, all those kind of actions. But yeah, we're at a stage where like kind of the core components of IncusOS daemon are there. So now it's pretty easy to kind of have multiple people work on different areas to like add features and kind of fill in the gaps. Once we are a bit more happy with the way the REST API works, then we can also work on the client side to have an actual Incus admin OS command within Incus that drives it, instead of just using the low-level Incus query to just poke it directly. But yeah, lots of progress. Everything is moving pretty quick at this point, which is great. We've got a lot of people interested in running that. We've got obviously needs for it to run in production. So yeah, it's great to see all the progress on it. All right, well, that was a very, very long live stream. I'm right around the 2 hours mark. Usually I try to keep it at an hour or an hour and a half, so it was definitely one of the longest ones. But yeah, hopefully it was pretty interesting as an update on the state of things, as well as basically building up that whole NVMe thing from scratch. So yeah, thanks a lot for everyone who's been watching all the way through this, and for anyone who's watching it afterwards online. If you've got any questions, feel free to leave them down below. You can go on our community forum, or you can go look at GitHub. As you can see, we've actually started to do a better job at tracking things directly as GitHub issues. I'm gonna try and do a brain dump of creating like a bunch more things on there, so that people can also give their input, or even contribute to the project directly if they want to. So again, thanks a lot for watching. I'll see you in the next one. Bye.